Static electricity can be generated in the solvent or on non-conductive surfaces such as plastic drums. Static electricity charge can be generated in solvents by liquid movement such as flow, mixing, pouring, pumping, filtering or agitation operations, where the movement separates electrical charges which may accumulate in the liquid and the containment system, such as pipes, tanks, drums, road tankers, rail cars and ships. If either of the materials is a good insulator, or the plant is isolated from earth, electrostatic charge will accumulate. A good example is liquid flowing through a pipe. Negatively charged electrons move across the boundary between the two bodies and are then unable to return. The charge on the containment system can be dissipated quickly by earthing, but the charge in the liquid remains and is slowly dissipated, depending on the conductivity of the liquid. How quickly the static electricity charge builds up depends on a number of factors. Turbulence of the liquid, the speed and contact of the liquid with its surface area of its surrounding equipment, the presence of impurities, and how quickly the earthing equipment can remove the charge. The amount of charge remaining after a given time depends on the amount generated and the amount dissipated. The time required to ensure the charge dissipates to a safe level is known as the charge relaxation time, which will vary with different solvents. Turbulence experienced in filling operations, caused by large flow rates, splashing, or free-falling liquids, greatly increases the charge accumulation beyond the level generated in pipes. Filters, because of their large surface area, can generate as much as 5,000 times the electrostatic charge generated in a pipe system without filtration. Dispersing operations can be particularly hazardous in view of the extremely high rate of charge generation when particulates are present. High charge rates can also occur when liquids containing non-miscible components are mixed or agitated. With poor conductive liquids, the charge accumulation can cause sparking in the vapor space to an exposed agitator blade in a mixer or to a filling pipe. Generally, it is recommended that plastic IBCs and drums should not be used for low-flash solvents, as the plastic surfaces themselves can become charged by brushing against them, and any charge buildup in the solvent cannot be removed. Some plastic containers have a special provision for earthing, and the operator must be satisfied that it is robust and reliable, earth-proofing equipment is available, and that any potential for brush discharge from the surface is eliminated. Earth-proofing systems offer a continuous confirmation of earthing and can prevent and halt operations if there is an earth failure. When filling road tankers, special earthing conditions must be made, as the resistance to earth of a vehicle can exceed the recommended maximum resistance. In all instances, the earthing clamp should be attached to the vehicle before any other operation, and should not be removed until all operations are complete and there is no presence of vapor. For situations where permanently interlocked filling systems are not provided and the use of portable equipment is required, for example mobile pumps, this equipment must be earthed back to the process equipment or common earthing system using the appropriate flexible cables and clamp. The clamp must make contact with metal surfaces through paint, rust, and surface contaminants. When discharging, the source vessel should be electrically connected to the receiving vessel. If temporary storage is used, an assessment of earthing provision and associated earth testing should be carried out. The equipment for dipping or sampling should be of conductive material throughout and bonded to the tank, or of natural fiber. Dipping or sampling should only take place after the appropriate relaxation time has elapsed. If flammable liquids are handled, static dissipative footwear should be worn and tested on a regular basis by all people present. The proper installation and effective inspection and maintenance of earthing and bonding systems and devices are important in the protection of personnel and equipment. To ensure a high level of static electricity awareness is maintained, there should be regular testing of equipment with results logged, frequent awareness training of operators, and reference to the appropriate standards. The fixed part of the earthing system, the earthing rods, the earthing loop, bonding on fixed equipment, should be tested periodically, usually by a specialist, often in conjunction with tests on lightning protection equipment. A typical test period would be 11 or 13 months, testing during different seasons, and would look for any significant variation from previous tests, indicating deterioration. Earth-proofing systems are normally tested every 12 months. Earth leads and clamps for portable equipment should be tested more frequently, every 3 months, using an intrinsically safe earth lead tester. It is essential that operators using flammable solvents are aware of the hazard of static electricity. We have shown how this hazard can be eliminated through good operating practice and use of tried and tested earthing and bonding equipment. Solvents have a vital part to play in industry and in many ways enable us to have the products and resources that are fundamental to our daily lives. Some solvents are hazardous, and this film has highlighted the particular hazard of static electricity. The solvents industry is well regulated, and there is information and advice to ensure the risk associated with this hazard can be minimized, including our recent film about the safe handling of solvents. Thank you for watching this short presentation.